Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. In the last video, we introduced standard position angles, along with coterminal angles and reference angles. And we also introduced the ASTC rule for the quadrants. Today, let's go deeper. We'll walk through some classic question types that students often see when working with angles in standard position. These will give you more practice and help solidify how these ideas connect to the unit circle. For our first example, we have our angle 17 pi over 6. First, let's go ahead and draw this angle in standard position. So we're going to start by drawing our x and y axes. And note that 17 pi over 6 can be written as 2 pi plus 5 pi over 6. Now remember the values that I told you to memorize from the last video, which are 0 and 2 pi. And then up on the positive y-axis, that would be pi over 2. The negative x-axis would be pi. And then the negative y-axis would be 3 pi over 2. So now, if our angle is 2 pi plus 5 pi over 6, that means we're going to go one full circle, which is 2 pi. And then we're going to go an additional 5 pi over 6. So you can think of 5 pi over 6 as 5/5 of the way towards pi. So if we divide up the top half of our xy plane into 6 equal parts, then that means 5 pi over 6 is going to be right over here. So then the angle 17 pi over 6 just means that we go one full circle and then we stop at this terminal arm. So that is our 17 pi over 6. So this is part A. Now part B is asking us to find the coterminal angle that lies in the interval 0 to 2 pi. This means we want to find the angle that lies within one full rotation. So since 17 pi over 6 is us going one full rotation and then another 5 pi over 6, then the coterminal angle that we want is going to be 17 pi over 6 minus that full rotation that we did, which is 2 pi. So this gives us 5 pi over 6. And then lastly, we want to find the reference angle. So recall that the reference angle is the angle made by the terminal arm and the x-axis, but it has to be acute. So in this instance, it's going to be this terminal arm here and the negative x-axis. So our reference angle will be this angle right over here. And from the diagram here, we can see that it is just one portion of our 6 equal portions. Or you can think of it as our reference angle plus 5 pi over 6 is equal to pi. And then solving for our reference angle, that gives us pi over 6. For our next question, we're given that our angle theta is in quadrant 3. And the point P has the coordinates -√3, -1, and it's on the terminal arm. We want to find the exact values of these 3 trig ratios. So again, we're going to start by drawing our x and y axes. We're going to place our labels, so that's 0, pi over 2, pi, and 3 pi over 2. So quadrant 3 is this one right over here. So that is our Q3. Next, we're going to go ahead and plot our point P. So that has an x value of -√3, which is somewhere around here, and a y value of -1, which is somewhere around here. So P is going to be right over here. So we're going to draw our terminal arm, which passes through the point P. And we're also going to label our reference angle. So that's going to be with the terminal arm and the negative x-axis. So this angle here is our theta r. Now let's go ahead and actually just finish this and draw our triangle here. Next, we're going to label our sides. So here, this would be -√3, and here, this would be -1. And if you remember your special triangle, you'll know that this is just the 1, 2, √3 triangle, so our hypotenuse here is 2. But if you don't remember that, you can always use the Pythagorean theorem to find the missing side, which means we would have negative root 3 squared, that's one side, plus our other side squared, which is negative 1 squared, and that is going to give our hypotenuse squared. So solving for this, we get 3 plus 1 is equal to r squared. And recall that the hypotenuse is always going to be a positive number, so therefore we take the positive square root. So r is equal to 2. And now we're ready to go ahead and find the values of our three ratios. So we have sine theta, which is going to be equal to opposite over hypotenuse. So that's going to be negative 1 over 2. Our cos theta is going to be adjacent over hypotenuse, which is going to be negative root 3 over 2. And then tan theta is going to be opposite over adjacent, which is going to be negative 1 over negative root 3. And that gets simplified to just positive 1 over root 3. For our third example, we're given that our angle theta is in quadrant 4. And we're also given what cos theta is. And we want to find the value of our angle theta, where theta is in between 0 and 2 pi. As always, we start by drawing a diagram. So Q4 is this quadrant right over here. We're going to draw our terminal arm. And then we're going to label our reference angle. So that's going to be this angle right over here. And then we're going to complete the triangle. So we know that cos theta is equal to 5 over 13, which means our adjacent side is going to be 5, and our hypotenuse is going to be 13. So that means this side here is 5, and this side here is 13. So now to find theta, we're going to need to isolate it in this equation here. So cosine of our reference angle theta r is equal to 5 over 13, which means we're going to take the arc cos of both sides. So theta r is equal to arc cos of 5 over 13. So to find that value, we're going to need to use a calculator. So arc cos on the calculator is this cosine inverse. So because the domain that we're given is in terms of radians, meaning we want to find an angle in between 0 and 2 pi, we need to make sure our calculator is set to the radians mode. So currently you can see that degree is highlighted. So we want to click on radians to go into radians mode. So now we're going to put in our cos inverse of 5 over 13. So that tells us our answer is 1.176. So let's go back here and write down our answer. So our theta r is equal to 1.176. But we're not done yet. So this angle is only the reference angle, which is not the actual angle in standard position, which is what we want to find. So now the angle that's in standard position is going to be the one that starts from the positive x-axis, rotates counterclockwise, because our domain here is positive, and then it stops at this terminal arm. So that is the theta that we want to find. But we know that our angle theta plus our reference angle is equal to one full rotation, which is 2 pi. So now we can go ahead and solve for our theta, which is equal to 2 pi minus our reference angle, which is 1.176. So then going back to our calculator and putting that in, that's going to be 2 pi minus our answer from above, and that is going to give us roughly 5.11. So our theta is equal to 5.11 radians. So notice how when I used the calculator, I didn't type in the reference angle that I got from the previous step. I used the answer button. And make sure that you always do that, because if you start rounding in between your steps, your final answer could be quite a bit away from the actual answer. So make sure that you don't round your answer until the very last step. And now we come to the last example of this video. Students often do something incorrectly with their calculator here. So be sure to watch this entire question so you don't make the same mistake. So we're given that tan theta is equal to negative 3 over 7. So we're going to start by drawing a diagram. We're going to label our quadrants with the ASTC rule. The reason we're doing this, because in this question, it doesn't tell us which quadrant our theta is in. So we need to use the ASTC rule to identify which quadrant. So since our tan theta is negative, that tells us our theta is going to be either in quadrant 2 or quadrant 4. So let's go ahead and draw the terminal arm in quadrant 2 first. So here is going to be our reference angle. And then we know that since tan theta is negative 3 over 7, that means our opposite side is 3, and our adjacent side is 7. And then we're going to do the same thing in quadrant 4. So it'll be right over here, and same thing, label our reference angle. Our opposite side is 3, and our adjacent side is 7. So notice how I didn't put the negative sign in there. And that's because we're going to use our quadrant knowledge to help us deal with that negative sign. So the first thing we're going to do is we're going to find what the reference angle is. So we would go to our calculator and do arctan of 3 over 7 is equal to theta r. So going back to our calculator, we get tan inverse of 3 divided by 7, and that gives us 0.405. So going back here, theta r is 0.405. And now using our diagram, we can go ahead and find our actual theta. So for the green one, that's going to be theta plus theta r is equal to pi, which means theta is equal to pi minus our reference angle. And then for the red one, we would have theta plus theta r is equal to 2 pi, which means our theta is going to be equal to 2 pi minus the reference angle. So let's go ahead and put both of those into our calculator. So our first one is pi minus our answer from the previous step, which gives us 2.737. And then our second one is going to be 2 pi minus the answer from the previous step. We're just going to take that entire value, put it in here, and that gives us 5.878. So our first answer is theta is equal to 2.74. And our second answer is going to be 5.88. Now let's take a quick look at what would happen if we just blindly relied on our calculator to solve this problem. So then what we would do is we would go tan inverse of negative 3 over 7. And that would have given us this angle here. First of all, this angle is negative, which means it's outside of our domain, which is 0 to 2 pi. But even if you were to realize that and add 2 pi to the answer to get the coterminal angle, you would have gotten only one of the solutions, mainly the solution in quadrant 4. You would have completely missed the other solution, which was in quadrant 2. So this is the reason why it is always good to draw a diagram instead of just blindly relying on your calculator for these trig questions. And now let's go ahead and do a recap of everything that we covered in this video. As demonstrated in this video, you always want to sketch a diagram to see where your angle lives. And after we sketch our diagram, we want to label our reference angle and remember that it's always positive and acute. If the question tells us which quadrant the angle is in, then go ahead and draw it in that quadrant. But if it doesn't, you want to use your ASTC rule to decide on the signs and the placement. And most importantly, don't just rely only on the calculator. Make sure to use your quadrant reasoning to get the correct answer. And now it is your turn to give this a try. Can you find the answers to these 3 parts of this problem here? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on angles and standard position in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.